Good morning, everybody. Who's feeling a bit ropey today? Yeah, cool. A couple of people. Nice. We're going to be talking about Advanced Search 101. This is a fairly heavy topic for a Thursday morning, especially after a late night. So let's all try and get through it together. As mentioned, I'm Callum. You can find me on various social media networks at that handle. But I'm an Umbraco MVP, now 8 times, Microsoft MVP 5 times, and a .NET developer by trade. I've done a lot of things with search and building quite large-scale technical solutions over the years. I currently lead an awesome team of Umbraco experts and Louis at Bump. We're based across the UK and Australia, where I also now live. I get to speak at loads of events all over the world. It's lovely to see so many of you here, and I organize a few of them myself as well. So why am I here to talk about search today? I've done a few talks on this. I've written a few plugins for search in Umbraco, and it's something I get asked about a lot. A lot of people come to me and they say, I kind of want to use Examine, but it's a bit scary, and I don't know where to get started. So I'm going to try and give a breakdown of how search in Umbraco works from a fundamental perspective. We're going to have a look at some techniques that you can do some more advanced, more powerful things, and also a little look at the future as well with what's coming in Umbraco. But first, I thought we'd start with a little history lesson. Given that it's the 20th edition of Codegarden, I thought we could start with a little bit of a walk down memory lane. So in 2004, Umbraco version 2 came out. That seems an awfully long time ago. Well, around that time was also the first time a search plugin of any sort was created for Umbraco, and that was XSLT Search plugin by Doug Robar. This was a fantastic plugin that I'm sure a lot of you used back in the day. It lived on from V2 of Umbraco all the way through to sort of V6. It was very popular at the time. Look at like 73 upvotes on our Umbraco back in the day. And essentially, whilst this was called search, it was using XSLT to filter the content that you had available to perform various filtering tasks by keyword. Doug made a really great implementation that you could use macros to drop this into any page on your site, and it worked well, and it was very fast because it was just filtering XML. But as time went on, people's needs for more advanced search became prevalent. And this is where a library called Umbraco Utilities, that later went on to become Umbraco Search, appeared in 2006. And this is the first implementation of Lucene.net in an Umbraco website. Now, I did a bit of digging because I wanted to go and find out a bit of information about this. It turns out 2006 was sort of the era of Yahoo Groups and Codeplex. Both of these things have been retired and long nuked off the internet. But I did find a mirror of the Yahoo Groups group from 2006, and there's all kinds of people in there, people's names who you would be familiar with in the community, talking about things Umbraco. It's quite a nice snapshot into the past. Yeah, of course, Codeplex was shut down a few years ago, and it used to be the place all of these open source projects lived. Unfortunately, it's long gone, and there are a few mirrors out there, but very few of the Umbraco repos. So if anyone does have Umbraco Search or Umbraco Utilities in a code base somewhere, I'd love to chat with you afterwards. It would be cool. But what I did find in my search was wikibooks, and from 2006, this is a community effort to make a kind of documentation handbook for Umbraco. People like Darren Ferguson working tirelessly to document every aspect of the CMS and the community. And this is the earliest mention of Umbraco Utilities for search that I can find. It's also mentioning Umbraco XSLT Search there from Doug too. So that was our first introduction to Lucene.net in Umbraco, and that's really become a mainstay. In 2009, Shannon and the team at the farm in Sydney created Examine. And Examine is what we use for Umbraco today for all of our search needs. Examine was created to be fast, stable, and ultimately usable. Lucene.net is a fork of Java's Lucene, and it is a vastly complex beast. Examine abstracts a lot of that complexity away behind a friendly, fluid UI, fluid interface for programming, as well as introducing some key hooks that allows Umbraco to hook in and index data and make it searchable. Now, of course, we talk about, oh, that's the wrong slide, never mind. We talk about Examine a lot like it's a search engine, and whilst that is maybe true anecdotally, that is not the case. We need to be quite clear. When we're talking about search in Umbraco, Lucene.net is the search engine, and Examine is an abstraction on top of it to make it friendly and easy to use. So whilst Umbraco is using Examine, the abstraction, it's not actually an Examine search engine. It's just building Lucene.net indexes in the background and that is what's powering search. Examine spawned a chain of, in my opinion, some really exciting things happening. People getting more advanced and building better functionality with search in Umbraco. In 2011, Regard Pfeiffer built the full text search package, which Soren has also now taken on and kind of modernized. This was the first real out-of-the-box search product that you could install into an Umbraco site. Then in 2013, the wonderful Matt Brailsford created Easy Search, which again was an easy drop-in to use Examine to all its potential in your Umbraco sites. And then in 2014, we started to see people really experimenting, getting a bit more advanced with what you could do with Lucene and bringing that to Umbraco. Anthony Briggs, Morten Bock, and a couple of other people wrote some amazing articles in things like 24 Days and Scrift about Bobo Browse. Bobo Browse is a faceting and browsing engine built on top of Lucene. And this was the first time we really saw truly advanced filtering and that type of functionality built in Umbraco. And then it gets more exciting. There's been an amazing wealth of content and articles and talks by some wonderful people over the years, including some packages. So in 2011, Peter Gregory, new MVP Peter Gregory, wrote an article about examining Examine. It's on the Umbraco.com blog still to this day. In 2015, my old colleague Ismail Mayat ran a workshop at the UK Fest, Seek and Ye Shall Find. And this was really a precursor to getting the community involved with Examine and starting to work in a more advanced way with search. That led to the search training that myself, Ismail, and a couple of others helped create at Cogworks that is now still on the training course today. In 2019, this is a bit of a shameless plug, I created a plugin called Examine Facets, which took that original Examine concept of building a fast, lightweight, and friendly UI, programming interface, API, around Lucene and started to define the same things for faceting engines, so Bobo Browse, Lucene Facets, and a couple of other open source libraries as well. And for me, this was a big turning point. It meant that we could start easily using faceting in Umbraco solutions without it really being too much work. And finally, 2025, maybe, Examine v4. And Examine v4 is what we're going to be talking a bit about today. Examine v4 has been a huge effort by Shannon, but also Chad and Nikolai from the community who've been working tirelessly to make an advanced version of Examine with faceting baked in, taking some inspiration from those original APIs that I defined in the Examine Facets library and actually making those available. It's currently as a pre-release on NuGet, and that's what we're going to be having a look at today. How do we plug that into an Umbraco website? Okay, so first up, I've got to go through some Lucene fundamentals. Now, I did a talk a few years back that was looking at how you can make search work in Umbraco and how you can make search friendly, and a lot of these slides are familiar. You can obviously go back and watch that talk on YouTube. It was from 2021, and it will go into a lot more detail than this. We're just going to give a brush over so you know the key terminology that we might be seeing today. So, as I mentioned already, Examine is this friendly, lightweight wrapper around Lucene.net. It is not specifically the search engine. When we're building a search in Umbraco, we are building a Lucene.net search engine. Lucene.net is this full-text search engine port from Java, and it's a very, very powerful in-process search option. We'll be talking about indexes. Indexes are where your data is stored for your search. This is a specifically structured way of storing your data that makes it easy and fast for search. An analyzer is the piece of code that runs through the content you're trying to store in your index and produces tokens. And those tokens are stored in the index in a certain format to make it easy to search. They also get tokenized through a tokenizer, and that tokenizer takes your tokens and breaks them into digestible, queryable values. And finally, you have filters. And the filter's job is when you do a search to go and match your query and your terms to the tokens that exist in the index in as fast a time as possible. Now, day to day, you won't have to touch any of these things. Examine sort of manages a lot of it for you. But when it comes to looking at building an advanced search experience, you do have to think about how you might utilize some of these tools that are available to extend the search index to be exactly what you need it to be. Lucene uses what is called an inverted index, and I've stolen this exact line from the official Umbraco training, but effectively, it's like the index at the back of a book. It's a list of keywords and terms with a corresponding page number. In this case, the page number being a document number. The index stores a list of documents, a collection of documents with lots of fields, and each of those values is stored in this inverted index. It means when you do your search for cat, the examine and Lucene work together to come back with a list of document IDs that match that result and give you a score for how much of a match that was. And that's how we can then build these powerful search experiences. Lucene uses a Boolean search system. And what this really means is when you're making a query for giraffes, unicorns, rabbits, you have to be quite explicit. So here where you're saying, I'd like to find articles with giraffes and unicorns or rabbits, that will give you back articles that contain both giraffes and unicorns or articles that contain rabbits. However, this alternative way of looking at it could be, say, I want an article with giraffes and unicorns, or maybe a rabbit instead, is sort of a completely different query altogether. There's very subtle semantics there, but the comma really makes a big difference. That would be saying, find all the articles that contain a giraffe and a unicorn or maybe a rabbit. So you have to start to think how you structure your queries when you're building and defining how your application might work, and how that might map to the underlying query that gets executed in Lucene. Lucene has these three concepts: a must, a should, and a must not query. And that boils down to a specific set of syntax in both Lucene and in Umbraco. So when you're performing a must query, that's the equivalent of an and you're saying, make an additive query where the fields must match this and this other value. That little plus that you see in your Lucene query there is effectively denoting an and. An or, the should query, is an or an examine is not going to have any operator, no plus, no minus, and that's effectively just saying this value or this value. The brackets here help denote what the groupings are. So if you want to group fields by this and this, you would wrap them in the same set of brackets. Finally, the must not, hopefully pretty obvious at this point. It's to say exclude these terms or exclude fields where this value matches, and you use the underscore in that case. I mentioned groups already. What's happened there? There we go. Groups already. Examine has a bunch of operators for grouped and, or, and not, so they have grouped versions of these operators too, and in doing that, it just encapsulates stuff in more and more sets of brackets with more plus and minuses around them. That's essentially all you're building up when you're using the Examine Fluent API. It's just building a set of strings that it then executes directly against Lucene. So Examine's not doing something all that advanced or fancy. It's effectively string building. Okay, so a really common scenario that we can use is we want to be able to query by path in Umbraco. We want to find all the nodes that live directly under a certain node. That could be our product section, or it could be the blog, or it could be if you've got multiple websites. So in this case, you would do a search for where the path includes the 2922, and that should bring back your results, except it won't. We'll talk about that in a minute. Another common scenario is being able to query by friendly name. I see this quite often, where you might want some filters or keyword search in your search engine, and you may have pickers, things like a category that gets picked from a set of nodes. Umbraco, by default, as you can maybe see towards the bottom here, will store that as a set of values. The UDI that Umbraco stores, the identifier, is broken down into document and then a bunch of numbers. So if I've selected a category called articles, I can't go and easily search for that because the value doesn't exist in the index. Now, what the training would tell you to do is to go and use an indexing event to modify the value that's being stored in the index. In this scenario, it would be to replace all of the paths with replace the commas in the path with a space separator so that you can independently search for each part of the path. For the querying by a friendly name, it would tell you to go and inject the name of the content node that was referenced or something like that into a field. And that's fine, but we're essentially adding extra fields to our index that maybe don't need to be there. If you think of an examine index like a big database or a big dictionary of values, the bigger it is, the slower it's going to be to process. Now, it is hyper efficient, so the reality is adding one field isn't going to make all that much difference. But it does add overhead to your indexing, and it does add overhead to actually querying as well. One of the biggest problems I've seen in sites that are using Examine and complaining it's slow or unreliable is doing exactly things like you've got there on the right-hand side, where it's doing a direct call to the cache or maybe even to the database to get a value. Those values become out of sync, and ultimately, this is just slow if you're doing 1 million calls to the cache as part of indexing. But if you do use that code, you will end up with these fields. Searchable path that is now separated out and looks all pretty and nice. And here, document, our ID, but then articles has been injected as well. So we can now query based on that field to say, find me all of the content nodes that include that value. The proper way, or the better way to do this, is to start customizing how you use the index and the indexing process. So you can create an analyzer, and that analyzer declares how it should interpret tokens, and you can say, I'd like you to automatically for me break down how you tokenize these values. In this case, this example takes the path field and separates the commas out already and says, ignore these, treat these as separate terms. So by default, it's already indexed correctly. This doesn't have any impact on Umbraco, and it doesn't affect how Examine or anything else functions in the site. It's quite safe to apply this. This just means the value that's going to be stored in the index, the tokens that get stored in the index, will not have the comma and will be immediately searchable by default. Similarly, you can do the same with pickers, content pickers. I've created a picker field type here, which does some of the same sort of stuff, but instead of injecting an extra field, we're no longer duplicating data. It now just stores some additional data in the index. I know there's lots of people taking pictures of this. It's all on my GitHub, so don't worry. But effectively, this is what you'd end up with, where before your value on the path field at the top there that would have gone in has commas. The output actually stores without the commas, and it makes it immediately searchable. The same for categories. So categories was previously storing document something, and that meant if you did a search for where the categories field includes the word it will bring you back every single document in your index. That's no longer the case. We don't store those. It stores the GUID, and it stores the friendly name for searching purposes. You can do similar with dates and sorting, but that's for another day. One of the fundamental concepts that Lucene is applying here is sorting or scoring your document. So the way that it determines which result is more important to you or which result matches your query best is through these these doc collectors or these doc scorers. Effectively, at the point you do index any data, that everything that's tokenized is scored against itself, against the index. So they predetermine how many times a certain term appears in a document, and they can then use that in the index to easily retrieve and promote results. You've got your top score doc collector, and that effectively will match based on your query and based on the terms you've queried for, how many times this matches, and it then pushes those results up to the top. You've got your top field collector, which is an alternative approach, where if you've applied your own manual sorting, it will then apply the sort for you as well, using this field comparator. The reality is you don't need to know too much about this unless you want to go and start doing some really low-level things in Lucene. Examine takes care of a lot of this for us. But if we move on to some more advanced scenarios, these concepts do actually become important. Faceting. So faceted search is essentially this idea that when I go to a search box, I should be able to see all of the different terms that are available to me for a certain criteria, creating facets of my search index. In this case, I've done a search for breakfast, and I'm able to identify that the words eat, drink, and cook appear X number of times in my results. This is a requirement that I see quite a lot in websites, and it's a requirement that I see done repeatedly wrong because people feel that this is unnecessarily complicated to implement in the search tools we've got available to us. Faceted search also allows us to create these experiences called browsing. And browsing essentially lets us select a term and then derive more facets from that to say, okay, when you select drink, then tell me how many of these, this type of field or these values in these fields appear. So you can then create this experience where, like you'll have seen on e-commerce sites, you select a category and then it reveals a bunch of other filters for you. This is entirely possible in Umbraco now with Examine v4, and has been in the past, but it's been pretty complicated. So this might be what our index looks like. We've got a table here with document ID. We've got our categories, which which have several values, and we've got tags. And that's essentially what we're marrying up here, so that when you select one of those categories, it should get a restricted list of the tags that only appear in those documents, and do so without having to crawl through every single value in the index and find all of those for you. Okay. When a few of you came in, I asked you to play a little game with me. So by a quick show of hands, who got a card when they walked in? Nice, cool, good. And I asked for 3 volunteers. One of them's there, Alex. One of them is here. One of them's there. Please stand up. So we're going to do a physical demonstration of why faceting in a search index is actually important. I asked every single person in this room that came at a certain time to write down one or many of these terms on their card. And I said that it was perfectly fine for you to write these terms multiple times. The way that some people do faceted search, or even just providing counts next to filters in Umbraco, is to get their entire set of results and to count each time a given term that they know already exists in those documents, and they surface those counts up to the UI. Now, just to prove how inefficient this is, we're going to do that in real life. Alex, I'd like you to choose a word from the wall. Giraffe. Fantastic. Giraffe. Choose a word. Tack. Umbra coffee. Good choice. Okay. Now my 3 wonderful volunteers are going to go round the room, and they're going to count how many times that term appears on each person's card, whilst I'm then demonstrating the next part of this talk. Off you go. Come back when you're done. Don't help them, please. Okay, so I'm going to really prove to you why this is inefficient. Here I have Paul Seal's Clean Starter Kit installed, and I've created a blog post. I've got a blog section, sorry. And that blog section lists about 5 different articles. But I can put the Umbraco, what's it called, the profiler on, and you can see this page right now takes 13.59 milliseconds, but it kind of varies. It's 20, 10, who knows. It's got 5 results on it only. You can see at the top here I've got filters. And what those filters are doing is we first get a list of all of the different blogs, and we can count through each of the categories that we know exist, and we find how many times each of those categories exists in the title or the description field for this search. This is all good. 11 milliseconds to load is pretty fast. But I've then got a blog that I've created that is Extreme Blog. And if we dive into this, this has got 10,000 articles in it. And you can quite quickly see how this doesn't scale linearly. I see my friends are done, but I don't really trust that you've done this accurately necessarily, but we'll trust you. Essentially, what they've done is exactly what my code here has just done as well. It's walked over every document, it's counted, and it's come back, and it's presented a set of results. In this case, where I had 5 articles before, I've now got 10,000, and this takes 400 milliseconds. It doesn't scale linearly, and it is not hugely efficient. You can see here, here's my lovely filters. So how could we make this a bit better? Well, Examine in v4 ships with faceting out of the box. And faceting allows us to create a list of terms and get their counts up front, making this 400 milliseconds go down to hopefully something significantly less. Let's look at some code. So here we are. I've got my results code, blog listing code here, and this is the current implementation. It gets a list of the child items for the current page, the articles. It does a bit of filtering by keyword. Don't worry about that too much. It then pages them. It gets the list of categories and does some other stuff. I see it's paging twice. Amazing. Doesn't really matter. It's quite inefficient. So instead, we can use Examine to do this exact same thing. Here I've set up a query that uses the external index to go and query all the items that live under this current node, the parent ID being the current page. I have then added this new line in, which is new with Examine v4. And this is saying, for this query, give me it with facets for this field. There's various different facet types that ship out of the box. So here, when I do facets, I can do facet float, double, long, so that's allowing you to do numeric range facets to say the number in this field is somewhere between 1 and whatever. You can also do it based on strings, and you can do it based on Boolean values as well, yes, no, true, false, etc. There was a little bit of work I had to do up front to make sure that my index was primed and ready to facet on that field, because Examine requires you index the data subtly differently if you're going to facet on it, and it stores the data in a slightly different format. We'll go over here to a composer class that I've created, where I have added a field definition for my categories field, and I've said that that field is using the facet picker type. In fact, this is something custom I've created. It's in my package that I'm going to provide a link to in a minute. But if we look in the field definition types, Examine actually now ships with a whole bunch of facet field type values. So for every field type, every time you're indexing data in a certain format, you can also declare that as a faceted version of that. And that enables it immediately to be available as a facet. If you expect that your field might contain multiple values at any point, such as in the case of a picker or a multiple text field, you need to declare it as a multi-valued field as well. So this line at the top here, facet config, set multi-valued fields for categories, and that now enables my field to be faceted. We call with facets, and then to get the facets out, we're just doing a quick type check. So the facet results that came back, was it an I-faceted results instead of an I-search results? If it was, let's go get the facet value out of the index. So to show you this in real life, I'm going to uncomment that bit of code. And if you look up here, this was 400 milliseconds. Let's give this a couple of refreshes. I think the first load will be slower, but this is now down to sort of 15 milliseconds, 20 milliseconds, and it's a lot more reliable. Same amount of content, exact same set of results, but it's using the Examine index instead. 3 lines of code to configure, 1 line of code to set up in my search query. It wasn't that difficult. We can go a bit further and we can do more advanced things when we start indexing our data. Things like hierarchical data. You can index your data to say that I have categories and subcategories. To do that, you need a slightly different structure of index. And that relies on using something called a sidecar index in Examine, which now they do completely for you. Previously, you'd have had to create this yourself and index all the data. But that's no longer the case. What you can do here is create a field and give it a definition type of facet with the prefix facet taxonomy. And if that exists, it automatically puts that field into another index. And Examine then knows, when you go to query and do the faceting, to go and look at this other index as well. Why would you do that? Well, as I said before, creating lots and lots of fields and putting lots of data into your index can make your search slower, can make your indexing slower as well. In this case, having the sidecar index means we can optimize that specific list of keywords and terms if you're just using it for counts or building up these kind of browse-based search experiences. So Examine now handles all of that for you, which before would have been a lot of code in something like Bobo Browse. And the experience is exactly the same. It's behind a nice, friendly API. A couple of things just to let you know here. I've thrown in some of my own custom code from my search extensions and facet extensions packages. This allows me to get items out of the index in a strongly typed manner. So in this case, because categories is actually a picker in the CMS, because I'm indexing my data in a format that can be correlated back to a content item, I'm able to get a list of category nodes that were picked, not just the IDs that I then have to go and look up myself. So with, again, a single line of code, you're able to index the data, get it out in a strongly typed fashion, and then use it. The counts also come kind of with you whenever you do a query. The data that comes out of Examine for faceting is going to be a dictionary of your value, a key, and a count for that. So essentially here, I'm just doing category name and then outputting the count. Where before, this was doing some awfully messy code to go and actually count all the items and is ridiculously inefficient. Highlighting. This is something that Google does, and sometimes clients want. They want the ability to do a search and then make sure that the terms that I've just queried are actually surfaced and highlighted in those results. Looks a bit more friendly and familiar for people using. the search. Now, that is not something Examine does out of the box, but it is something that Lucene does now via a plugin, an extension that you can install. Previously, in versions of Lucene 2 and below, there was a library called Lucene Contrib, which was a bunch of community-generated extensions that you could hook in and do some of these things. Now in Lucene.NET 4.8, a lot of those are embraced directly into the core and are supported by the Lucene.NET team. So with highlighting, we can start to build up quite a nice, friendly, advanced search. I'm talking things like this. If I was to search for the word podcast and hit search, maybe I'll do it on the non-extreme blog version just to check. Oh no, I've not commented, I've not put the code in, that'll be why. Ignore me. So, it's here. Wicked. So yeah, we want the ability to highlight our results. And if I put that in now and search podcast, try another one. Live demos, eh? Community. Community's bold, wicked. So that's now bolding the terms based on what I've searched. How is this working? Well, Lucene has a bunch of very helpful plugins, as I mentioned, to do things like this. One of them is called Lucene.NET Highlighting, and you can install that, and it brings with it a bunch of helpers and some tools that we can query to go and highlight text. Essentially, all this does is pick up on values that have been put into the field that are in your tokens, and it matches them based on a list of values that you provide. So in my case, I passed in a list of the values that I currently have, that someone's queried for, the text, and then I'm using the query parser to identify exactly what terms I should be looking for in my text, and then the Lucene highlighter to go and highlight the data. Okay, this looks like a fair bit of code, but I'm not actually calling anything directly in Lucene here. This is still vaguely using the examine abstraction. So the search context is a slightly new thing that's been introduced as a way of fetching data about the underlying index rather than using examine's abstraction. Examine doesn't have an abstraction for getting highlights, but once I've got that, it's very possible to go and get at the underlying index searcher and apply my highlighter. So with a couple of lines of code, it's possible to add kind of a Google-esque filtering feature. Now, suggestions and similarity. This is a slightly unknown API in the Lucene toolset. It's again a plugin that you need to install, but this allows you to do things like spell checking and also powers things like finding and highlighting keywords that are in your search. A way of saying, if I've typed Umbraco with an N, but I have actually searched for Umbraco with an M, that those terms are loosely the same, and you can sort of define exactly what the same means. So this is where we start looking into the underlying algorithms that actually are available out of the box in Lucene. And there's 3 different distance calculation algorithms that exist. One of them is the Levenstein algorithm, and this essentially counts all of the characters in a given word and compares them against the characters in another word. And it decides how many operations are needed to make the words match, or what's essentially different. So if you have a scenario where the word is Umbraco with an M and Umbraco with an N, it will go and count, okay, U, that's the same, M, N, that's not the same, so there'll be one operation to change these, and then the rest of the word is the same. Therefore, your Levenstein distance would be 1, and you can use that to determine, okay, a word is similar to another word if it's within X distance of that other word. So in our case, we can say if it's within a distance of 1, it is considered to be the same word. The Jarrow-Winkler algorithm is a nice fun one, and this is where I asked ChatGPT to do some maths for me, because I am not smart enough to understand any of this. Essentially, it works out how many of the characters match within a range, and then it transposes any characters. So the order of the characters doesn't actually matter, and this is quite interesting. So if I had Umbraco, but I put the N on the sort of, halfway down the word instead of as the second character, it would potentially still consider those to be a match. Whereas with the Levenstein distance algorithm, those would not be considered close because every other character in the string would have been different. It does some all fancy advanced maths, but according to ChatGPT, if I have Umbraco and Umbraco, they are 0.905 similar. So quite similar to the result we got before, which was it's within 1. This was in 0.1. It's just a percentage, so I think that's, quite similar in approach, but ultimately they function in different ways. And then finally, we've got the n-gram algorithm, and the n-gram algorithm chunks your words into sizes of n. So let's call n 2, which is what I've told ChatGPT to use in this case, and it would take the first 2 letters, and then the third and fourth letter, and the fifth and sixth letter, and it will compare those in each word and determine how similar each of those chunks are instead. So in this case, we get a completely different result. If you treat that as a percentage, it's saying these 2 words are 65% similar, not 90% similar, just like the Jara-Winkler algorithm would tell you. So in this case, it's actually really important to decide which algorithm you want for your behavior. If you're trying to get some advanced matching capabilities out of Lucene, you need to decide exactly which one to use. You can also write your own. I wouldn't recommend writing your own algorithm, but if there's another one out there that you really think is worth implementing, you can. And there's plugins out there for these various things as well. Okay, let's have a look at this in action. So there's no need to change anything about your current search index to make this work. But for efficiency's sake, much like with our faceting, it's sometimes good to put your data into a separate index if you're going to do a very specific purpose, use it for a specific purpose, and you need to format it a certain way. So in this case, for spelling suggestion, I've actually created another index called spellcheck index. If we look over here in my composer, to create an index, you can do this directly on the service collection in .NET. So you can say add examine Lucene index, you give it a name, and you can define some fields. In my case, I've said I've got one field in my index called keyword, and that field is a full text type. So I'm able to query the data within it in a full text fashion. It gets indexed and tokenized much like any other bit of full text data would. Then, inside my search here, I'm able to go and find my spellcheck index, and I'm able to go and query that index. What I'm doing at first is checking to see if the keywords that I'm actually looking for, if they directly match anything in the index. We assume that this word has been spelled correctly because it exists, so it's based off our existing list of terms. But if we don't match any results, we then want to go and do another check to see if it can suggest any words that are within a certain similarity of that term. So in this case, we pass our keywords to the spell checker class. This exists in that Lucene.NET similarity library. And you can then say to suggest similar. You pass it keywords, you pass it a distance, an allowable similarity, and then you can also suggest, change how it will respond, whether it will suggest things that, if it should always make a suggestion, or if it's only like if the value's really popular, or that sort of thing. It can get quite complicated. Shall we give this a go? So I have got here some logic that, oh yeah, that's me testing something. Ha, good fun. Some logic here that says, if the total number of results that came back from my original search were less than 3 results, then we might want to put a, hey, did you maybe mean this other term? Bit of logic in there. And so we'll call off to the spell checker to determine if our index has any terms that are vaguely similar, and if they are, it will then suggest make a suggestion. So in this case, I'm going to type Umbraco, as I've been doing. Okay. Is there even any results for Umbraco? There is. So that should work. Okay, I don't know. Sorry, I've only got 4 minutes left, so we'll skip that demo. But essentially, that code is correct. I don't know what's happened. Let's talk about the future quickly. And before I go any further, I want to say that Ken is doing a talk in this exact room in a few minutes' time about the future of search in Umbraco. I'm not trying to steal any of his limelight. It's going to be an awesome session. I'm really excited about the future of search in Umbraco for a couple of reasons. So there's an ongoing project at some point to replace how search is implemented in Umbraco, the abstraction that Umbraco uses to deal with search. To be crucially clear, that is not replacing Examine in Umbraco. Examine will still remain. But where right now we're interacting with Examine's API directly, going forward it will be hidden behind an abstraction. The benefit of that is we can write the same code and use it against a vast array of different search providers, whilst Umbraco is ensuring it's still efficient and accurate, and doing all the things that Examine set out to do in the first place. Examine is a fantastic implementation around Lucene.net, and I personally believe Lucene.net is still the single best search solution for a .NET application if you don't want to depend on a cloud service. But they're implementing a new abstraction around the APIs, and it will change fundamentally how we search for data in Umbraco. What it also means is faceting is becoming a first-class citizen in search, which it hasn't been till date. You still need to use the pre-released Examine, even to use it properly in the latest versions. The future looks something a bit like this. Ken might tell me I'm wrong, and he'll have changed all of this in his talk later. But we're going from using a fluent API, where we're declaring, where it's very declarative, to this more object-oriented based approach, where you build these filter classes, and the filters are responsible for encapsulating your search logic, which I really like, because it means that you can reuse things across the board. In this case, I've created an exact filter class, which is an abstract class Umbraco ships, and inside I've passed in a type, and then you're required to provide 3 fields. The field name, the operator, how you'd like to treat it. Is this a direct match? Is this a not? That sort of thing. That in itself, filter operator, is an abstraction around Lucene's must, should, and must not. And then you provide it some values as well. You can do faceting quite easily too by simply implementing a class that I've not implemented fully. But it leaves all of the implementation detail to the individual provider, and you don't have to then know how to configure your different indexes, things like that. Filtering, where would have been a Fluent API before, now becomes just a collection of classes that you pass along, and you say, these classes contain all of the logic and the information you need to go and filter my results. Ken's session is going to go into that a lot more, of course. And that's that one. Another exciting addition that's coming to the changes in search is the way that indexing works in Umbraco. And whilst indexing right now can be a bit inefficient, I mentioned before, people put a lot of code that runs at index time to manipulate indexes, or they go creating custom indexes that have to be built everywhere. All of the indexing data, the data parsing to make it ready for indexing, is going to be done up front. And that makes it a lot more efficient to do. So the individual provider can take that already structured, well-formatted, ready-to-search data and pop that into their system and interpret it and parse it how they need. So kind of all the things I've showed you today about you might need to change your index to do this or to optimize stuff essentially goes away. It becomes an implementation detail. Okay, very quickly. So a couple of resources that you might want to take away. Examine v4, as I mentioned, is this pre-release version of Examine that allows you to do faceting with 3 lines of code really efficiently. You can take your, I'm going to loop through loads of nodes in memory, down to 10 milliseconds reliably and very fast. The future of search, RFC, which Ken is also then talking about in his next session, is here. It's a really good read if you want to know why Umbraco is doing what it's doing. And finally, Search Extensions is the plugin I mentioned that I've created that wraps around a lot of these APIs to make them as friendly as possible for you to use with things like strongly typed objects, mapping pickers, and the IDs, etc. And with that, all of the code that I've showed you today is on my GitHub. I'm on Twitter, I'm on Blue Sky, I'm on LinkedIn, and I'm around for the rest of the conference. Thank you very much.